All right, we're going to take a look at the alternate exterior angle theorem. And what we'll find out is that the alternate exterior angle theorem is going to be almost identical, alternate exterior angle, almost identical to the alternate interior angle theorem, just with some minor changes. Because they're basically the same thing as far as what we're trying to prove and how we're trying to prove it. So what it says is, if two lines are parallel, then the alternate exterior angles are congruent. So just like before, I'm starting with this hypothesis that says that if two lines are parallel, just like any of these proofs in this set, they're all starting the same way, and then I'm trying to prove something about the angles, in this case that the alternate exterior angles are congruent to each other. So just like before, if I want to write this proof, I need to start off with a diagram. Here's my diagram. I've got two lines that are parallel to each other. I will mark them as parallel this time. And then I have a transversal that crosses both of them. And I will label all of them, P, Q, and T. And then I should label the angles. So 1, 2, 3, 4, 5, 6, 7, and 8. And so now I need to ask myself, what do I need to prove here? So if I'm trying to prove that the alternate exterior angles are congruent, I need to find a pair of alternate exterior angles. I have two of them. I have either 1 and 7 or 2 and 8 to pick from. So when I go to write my given and my proof, my given will be the same as before, which is that P is parallel to Q, and my proof will be just one of those pairs, whichever one I want. I like 2 and 8. Why not? Angle 2 is congruent to angle 8. So I'm going to prove that those two angles are congruent to each other based on the fact that these two lines are parallel. So I'm going to start off my proof, no thought put into it, just going to write down my given, and then I'll put a little thought into this. So P is parallel to Q, 1 is given. Okay, so let me think about where I'm going with this again. So my goal is to prove that 2 and 8 are congruent to each other. That's my goal. And so just like last time, I'm going to use vertical angles to my advantage, and also I'm going to use the only set of angles that kind of bridge this gap between the angles that are up here on line P and the angles that are down here on line Q. And that tool that I have to my advantage, that I can use to my advantage, is the corresponding angle postulate. So, for example, I can talk about, let's use yellow this time, if I can talk about 2 and 6 being congruent to each other because they're corresponding angles, I can talk about 6 and 8 being vertical angles and link this all together with the transitive property. That's going to be my goal, and that's how I'm going to step through this. So let's jump right in. Let's start with angles 2 and angle 6 being congruent to each other. This is statement 2. Angle 2 is congruent to angle 6. The reason for that is the corresponding angle postulate. It says that if two lines are parallel, then the corresponding angles are congruent. Okay, so I'm going to check myself here to say that then the corresponding angles are congruent. That's what I'm saying right now. How do I know that? That if the two lines are parallel, where did I say that? Up here in 1, so I will cite that here. And so I can move on to the next part then, which is talking about my vertical angles. So 2 and 6 are congruent. Now I want to talk about 6 and 8. And so from the diagram, this is only one of the two things I can assume from a diagram. I can say that angle 6 and angle 8 are vertical angles. So this is statement number 3. Angle 6 and angle 8 are vertical. Give a good reason for it, and that would be just assumed from the diagram. Assumed from diagram. And then I can say that they are congruent to each other. How do I know? That's because they're vertical angles. So angle 6 is congruent to angle 8. So you can see this is a very common pattern. We've used this now a couple times in this proof and in other proofs, that I will always state that the angles are vertical, and then I can say they're congruent afterwards. So why are they congruent? If two angles are vertical, then they are congruent. Okay, so I'll ask myself again, what am I saying? Then they are congruent. That's my statement. My hypothesis is if the two angles are vertical. Where did I say that previously? I said that over in statement 3. And so now I can jump to my final thought, which is that angle 2 and angle 6 are congruent, and angle 6 and angle 8 are congruent. And so since both 8 and 2 are congruent to the same angle, they'll be congruent to each other. And so that is otherwise known as the transitive property. So transitive property is what allows me to link these two things together. And so I will cite those two statements. The two statements I'm linking together are 2 and 4. All right, so that's my proof of the alternate exterior angle theorem, which is almost identical to alternate interior angle theorem, just for alternate exterior angles, of course, this time. I am using the only thing that I can link these sets of angles together. I'm using the corresponding angle postulate to link these angles up here on P with angles down here on Q, and then of course I'm using my vertical angles again to actually get to my, or to use a transitive property here and say that the alternate exterior angles are congruent to each other. So that's my proof. Again, not too bad. And so now I can use this moving forward.